Imagine this, a drone, maybe no bigger than a dinner plate, and it's weaving through a forest, a really dense forest. It's dodging branches with just impossible speed. It banks hard to fight off a gust of wind and then holds its position with millimeter precision. All of this with no human pilot anywhere in sight. It's honestly like watching a ghost at work, a mind inside the machine.
So how does it do that? How does a bunch of circuits and motors and plastic achieve something that feels so, well, alive? That's the big mystery we are going to solve together right now. We're going to find that ghost in the machine.
All right, so where do we even begin? We start with a map. This right here is our blueprint for the whole journey. I know it looks a little complex, but trust me, every single answer we're looking for is right there. We're going to keep coming back to this as we uncover each piece of the puzzle.
And the first secret, maybe the most important one, is that an autonomous drone doesn't just have one brain. It actually has two. One is all about reflex, and the other is all about reason.
So first up, you've got the Flight Control Unit, the FCU. Think of this as the drone's brainstem. It handles all the instant gut reaction stuff, staying balanced, tweaking the motors thousands of times a second just to fight gravity. It's the part that literally keeps it from just falling out of the sky. Then you've got the onboard computer. This is the higher brain, the cerebral cortex. This is where the real thinking happens. It's constantly asking, where am I? Where am I supposed to go? Is that a wall coming up? It's in charge of sight, planning, and all the big picture strategy.
And this isn't just some abstract concept. Check this out. This is a Pixhawk. It's a real-world FCU. This little black box is the drone's nerve center, and it's absolutely packed with sensors that are constantly feeling its every single move, just to keep it perfectly stable.
But of course, that hardware, that nerve center, it's just a body. It's nothing without its soul. And in this case, the soul is a really sophisticated piece of software called PX4. You can think of it as the digital pilot that actually lives inside the FCU.
Now, if you were to actually map out the entire software architecture for PX4, you'd get this. Whoa. Yeah, it's a lot. Pretty intimidating, right? But don't worry, we are not going to get lost in all those lines and boxes. Because the secret to understanding all of that is that it really just boils down to a constant, super fast three-step loop, a little dance. Step 1, estimate state. The drone asks itself, where am I exactly? What's my precise pitch, my roll, my altitude? Step 2, control position. Then it thinks, okay, based on my mission, where do I need to go? And finally, step 3, mix outputs. It calculates, all right, how much power do I need to send to each of my 4 motors to get there? And it does this whole dance hundreds of times, every single second.
So how on earth do all these different software modules talk to each other that fast? Well, they use a kind of internal nervous system. It's called URB. It's basically a super fast message highway that lets the part of the brain that senses the world instantly tell the part of the brain that controls the motors what's going on, with pretty much zero delay. It's incredible. Okay, hold on. So we've got the reflex brain, that's the FCU, running its super fast software. And we've got the thinking brain, the onboard computer, planning the mission. But these are two separate pieces of hardware. So how do they actually talk to each other? How does the thinker tell the doer what to do?
And right here, this is the aha moment. This is the key. The two brains communicate through a special kind of translator. It's a software bridge that lets the thinking brain give a simple command like, hey, fly over there, and it translates that into the thousands of tiny little reflex adjustments the doing brain needs to pull it off perfectly. This bridge, this is what connects everything.
Now, obviously, with something this complicated, you can't just upload all this code, take it outside, and, cross your fingers. One tiny bug, one little miscalculation, and your $1,000 machine turns into a pile of junk. So where do you test and perfect a digital ghost? Well, you do it in a digital world.
What you're looking at here, that's not a real drone. It's a digital twin, and it's flying inside a hyper-realistic physics simulator called Gazebo. In here, developers can run the exact same flight code they'd use in the real world and test every command, every crazy scenario, without ever risking a single real propeller.
And what's really cool is this virtual drone can be controlled just like a real one. Developers use a ground station like this to plan out complex flight paths, monitor the drone's health, and send it commands in real time, all while the drone is still just a ghost in the simulation.
And this is where it all clicks. A developer types in a simple command, just a single line of code, and instantly the digital drone responds, executing that command perfectly inside the simulator.
This right here is the magic moment. You see abstract code become physical action, and it's all perfected in a safe, digital world before a single propeller ever spins for real.
So now let's go back to our map, our blueprint. And suddenly it doesn't look so complex anymore, does it? It actually tells a story. The thinking brain, the onboard computer, dreams up a plan. It whispers that plan to the communication bridge to the reflex brain, the FCU. And the FCU, running its lightning-fast software, makes it all a reality, all while being watched from the ground. Every piece has its place, and now we see it. The mystery is solved.
So let's just nail this down one last time. A drone has a reflex brain, the FCU, and a thinking brain, the onboard computer. They're connected by a brilliant little translator, and the whole system is perfected in a completely safe, virtual world before it ever touches the sky. That is the ghost in the machine.
So we've solved the mystery of how it thinks. We've seen how perfectly it works in a clean, digital world. But what happens when this ghost in the machine finally meets the total chaos of the real one? You know, the unpredictable wind, a GPS signal that suddenly drops, a bird that just comes out of nowhere? Well, that's a story for our next explainer.
Hare hare!